So now let's take a look at some properties of vectors and some of the ways in which some of the notations that we use to express vectors. I'm going to go ahead and draw a vector on this xy coordinate plane. Okay, so I'm picking the point 7, -2, and I'm also going to pick the point, the origin 0, 0, and I'm going to draw a vector between those 2 points, starting at the origin and ending at 7, -2. So this is a vector, and like all vectors, it has a magnitude. And the magnitude is the length of this arrow, and is also the same thing as the distance between the origin and the point 7, -2. The direction of this vector can be expressed in many different ways. And one of the ways we can express both the direction and the magnitude is by giving a coordinate label to this vector. We're going to call this vector, and notice the brackets we're going to use for this vector are angular brackets. We're going to call this vector 7, -2. Okay, now that is defining a vector that looks just like this. It has this same distance, it has the same direction. And you look at these two notations and you'll say, well, why is it that we have to use a different notation? Can't we just use the coordinate notation 7, -2 with the rounded brackets? Why are we making a special notation with angular brackets? And that's because a vector isn't quite the same as this particular arrow. A vector represents any quantity, any object that has both a magnitude and a direction. We've chosen the tail for this vector to begin at the origin. But the vector does not have to begin at the origin. It can begin at any point on the coordinate plane, and it will still have the same magnitude and direction. So let's say, for example, that we chose to start this vector, we chose to put its tail up here. Okay, so we chose to put its tail at point, let's see, this would be x is 2, and the y value would be 1, 2, 3, 4. Let me do that. 1, 2, 3, 4, 5. Let's say we chose to start the vector there. Its tail would be there. What would the vector look like? Well, now, just like we counted off 7 to the right and 2 down, we would do the same thing from this starting point of 2, 5. So we go 1, 2, 3, 4, 5, 6, 7, and then down to 1, 2, and this would be the head of the vector. So we could draw the vector with the tail 2, 5 as being this object. Okay, now this point here is not 7, -2. In fact, let's figure out what it is. It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. It would be 9, 3. But the notation for this vector is still 7, -2 with the angular brackets. Well, why is that? Well, that's because, first of all, these two vectors are exactly the same. The fact that this vector is starting at point 2, 5 and this vector is starting at 0, 0 has nothing to do with the vector definition. Okay, remember, the vector is an object that has a magnitude, which is a length, and a direction, which is this direction. But in the definition of vector, nothing is said about a starting point. So the vector can start anywhere, but wherever it starts, it will have the same length and the same direction. Notice these two vectors are parallel. We could draw this vector from another starting point if we wanted to. Let's say we draw it from this starting point. Okay, this starting point would be -4, +4. So let's draw this same vector from that starting point. And we do it the same way. We'd have to count 7 across to the right, 7 in the positive direction in the positive x direction. 1, 2, 3, 4, 5, 6, 7, and then 2 down. And this is where the vector would end. Let's draw this arrow. This vector is also bracket 7, comma, -2. But it has a starting point of -4, 4, and let's see, it ends up at 1, 2, 3, comma 2. It ends up at point 3, comma 2. And you'll notice this is also parallel to these other two vectors. We could go on and on like this. We could pick any starting point we want and then make that the tail, move 7 to the right, and move 2 down, and then create the arrowhead. And in all cases, we would end up with a arrow that has the same length as all of these three do, and the same direction. As you can see, they all have the same slope. They're all somewhat sloping downward, and they're all parallel to each other. So I hope you're starting to get the idea of why we use this notation 7, comma, -2 in angular brackets. It tells us two things. First of all, if we choose to start the vector at the origin, it tells us what the ending point would be. Okay, so in this case, the ending point is going to be 7, comma, -2, but that's only true if we start the vector at the origin. But in all cases, what this tells us is it tells us how to calculate the head of the vector given the tail of the vector. In other words, if we're given the starting point, these brackets tell us how far we have to go to the right, 7.7 units to the right, and then how far we have to go down, in this case it's 2 units down, to create the ending point of the arrow. So 7, comma, -2 in the angular brackets tells us that wherever we start our vector, we've got to make that the starting point, move 7 to the right, move 2 down, and then make that the end point. And we could have generalized this for any numbers, but we're looking specifically at this vector 7, comma, -2. Well, with some of that as background, let's go ahead and start answering some of the questions on the notes sheet.